You ever see that little lock icon up in your browser's address bar and just, trust it? Well, have you ever really wondered what's behind it? It's not just a cute symbol. It's the front door to this massive, incredibly complex system of digital trust that pretty much runs our entire online world. Today, we're going to pull back the curtain and see how it all actually works.
So here's our game plan. First, we're going to talk about why the internet has a trust problem to begin with. Then, we'll get into the solution, this elegant little dance called the digital handshake. We'll see how this whole chain of trust gets built, and more importantly, what happens when it breaks. From there, we're going beyond the browser and into the enterprise world, and we'll wrap up with the huge challenge that companies are facing right now, managing all of this at scale.
You have to remember, the internet at its heart was built to be open, not secure. It was like the Wild West. So when you send any information out there, a password, your credit card, anything, it's bouncing between all these different computers. And without some kind of verification system, you have absolutely no way of knowing if you're talking to your bank or to a scammer who just looks like your bank. You just don't know.
So this is the fundamental question, right? How can we possibly build trust in an environment that is, by its very nature, untrustworthy? When you're about to hit buy or log in, how do you get that peace of mind that your data is safe and you are who you think you are? Solving this exact problem led to one of the most important inventions in internet security.
And the answer to that trust problem is a protocol. It's a set of rules designed to create a secure, private, and authenticated conversation between two computers. It started out as SSL, which stands for Secure Sockets Layer, but it's since grown up and evolved into its much more modern and secure big brother, TLS, or Transport Layer Security.
Now here's a key thing to know. Even though all the tech folks will correctly call it TLS today, the old name SSL just stuck. It's kind of like how we still dial a phone number. So you'll hear people use SSL and TLS almost interchangeably. But they're both talking about the same core technology, the magic that powers that lock icon and turns HTTP into the secure HTTPS. So before a single piece of your data gets sent, your browser and the server do this thing called the TLS handshake. Just think of it like a really fast, secret meeting. Your browser goes, "Hey there, here are all the secret codes I know." The server replies, "Nice to meet you, let's use this code, and here's my ID to prove I'm legit." Your browser takes a look at that ID, and if everything checks out, they both create a brand new one-time use secret key. And from that millisecond on, everything they say to each other is completely scrambled.
Okay, but wait a minute. That brings up a huge question, doesn't it? During that handshake, how does your browser actually know that the server's ID, its certificate, is real? What stops any bad actor from creating a fake ID for, say, Google.com and tricking you? The answer is a whole ecosystem called the Public Key Infrastructure, or PKI. And the best way to think about it is with a passport analogy. The digital certificate is the server's passport. It proves its identity. But a passport is only worth anything if it's issued by a government you trust, right? Well, that's what a certificate authority, or CA, is. They are the ultra-trusted passport offices of the internet. Your computer's operating system already has a built-in list of these trusted CAs. So when your browser sees a certificate, it follows the signatures all the way back to see if it comes from one of those trusted roots. That's the chain of trust. So this system sounds pretty solid. We have trusted passports. But what if a passport gets stolen? Or what if the passport office makes a mistake and gives one to the wrong person? In the digital world, certificates can get compromised. And we can't just sit around and wait for them to expire in a year or two. We need a way to cancel them, right now. And that's called certificate revocation. Now, to handle this, browsers have basically had two main methods. First, there's the CRL, the Certificate Revocation List. It's basically a giant most wanted poster of all the bad revoked certificates that your browser downloads every so often. The other method, OCSP, is more like making a direct phone call to the passport office in real time and asking, "Hey, is passport number 12345 still good?" Now, you'd think the real-time check, OCSP, would be way better, right? But, and this is a really fascinating twist, it turns out it has some serious flaws. Every time your browser makes one of those phone calls, it's telling the certificate authority exactly which website you're visiting. That's a huge privacy problem. Plus, an attacker could potentially block that call, tricking your browser into thinking a bad certificate is actually okay. Because of these issues, the industry is actually shifting back to the older, but more private and reliable CRL method. Okay, so we've been focused on that lock icon in your browser this whole time. But here's where things get really interesting. That same certificate technology? It is the quiet, unsung hero of almost all modern corporate security.
Its job goes way, way beyond just making websites secure.
Seriously, in a big company, certificates are everywhere. They're the reason your work laptop can just magically connect to the secure office Wi-Fi. They're what proves it's really you when you log into the VPN from a coffee shop. They secure the communications for all those smart IoT devices. They power single sign-on systems, you name it. It's the same core idea of a trusted digital passport, just applied to everything.
Whoa, okay, I know this looks complicated, but don't worry about reading every single box. This is a policy engine, and it shows the real power here. An IT team can literally build rules that say things like, only a company-owned laptop that's fully patched, belonging to someone in the engineering group, can access this specific server. And the digital certificate on that laptop is the passport that instantly proves all of those things are true.
And here is what success looks like on the other side. This is a log file. It shows the user connected, their certificate was checked and validated, and the system instantly recognized their roles. Look, you can see admin and VIP right there. And based on that trusted identity, the network automatically gives them exactly the access they're supposed to have and not an inch more. It's beautiful. So, this brings us to the final and maybe most critical part of this whole story. This all sounds great, but when you don't just have one digital passport, but thousands or even millions of them for every single employee, every server, every device, how in the world do you keep track of it all? Just take a look at this. This table is just a tiny little glimpse of all the signals a network administrator has to watch. You've got good stuff like someone getting access, but you also have all these red flags, an expired certificate, a revoked one, a flat-out authentication failure. Trying to monitor all of this in a huge organization is a monumental task. And the stakes for getting this wrong? They are incredibly high. A single important certificate expires, and a whole critical service can go down, costing a fortune. A stolen certificate could let an attacker sneak into your network. It can cause you to fail security audits. And at the end of the day, it completely undermines the foundation of modern security ideas like zero trust. And that's really what it all boils down to. That simple little lock icon you see every day represents this vast, powerful, and pretty complex world of trust. From your web browser to the very core of corporate security, it's all running on these digital passports. So the final question isn't if your organization is using them, because trust me, it is. The real question is, who's minding the store? Who is managing your trust?